Hey everyone, Stefan here from Be a Python Dev. Today I'm going to go over a coding challenge from one of the fellow moderators posted in the Facebook group. I'll go ahead and leave that out just in case for privacy reasons. But the question is kind of simple in theory. So write code to handle, let me change the spacing a little bit. Write code to handle admissions for a school. The rules, they need to pass the test in the interview. If they're a legacy, meaning their parent went to the college before, passing either the test or the interview is enough to be admitted. So yeah, and then we got these input data structures, the applicant's name, their test was okay, the interview went okay, and if they're a legacy or not. So Sue, Bo, or she, their parents went to the thing. Your output should be sorted, accepted students, and Bo, and blah blah blah. So let's just real quick see what we can do about this in terms of like just writing a simple algorithm. So for A and applicants, and this is complaining because these aren't actually inputs to our thing. You can see the taskbar. It's 21 degrees and sunny, which is a lot different than yesterday where we got 20 inches of snow in one day. That was fun. But alright, so now we have these. Alright, I think you just do sorted applicants, and that will just use a basic sorting thing based on these inputs. These are list, and these are all list. So to do lookups on a list, it's on. If we convert these to sets, it's still initially on to convert it to a set, but any further lookup will have much faster results. So I'm just going to go ahead and convert these to a sets. I still think this works. I can't really remember. I think you can also do dot sort. You can do something like this. I think both of these are valid ways. The dot sort method, you can specify your sort criteria, and sorted is just a basic sort. I'm just gonna go ahead and run this real quick, just to make sure it does what I want it to do. So sorted input will give you sorted output based on these right here. The rules are pretty straightforward. There's not a whole lot of clarifying questions I would want to ask, but later on I want to turn this into a system, so it will be extensible for new applicants. Let's just go ahead and run this. I should have had an output before. Oh, I guess I just need there. Alright, so you can see we're printing sorted here, and down in the console, make sure my face is not in the way. Doesn't look like it is. Right here, we have and Bo, J, Lee, Mo. So this looks like it's doing the right thing. I think it does it. Does it do it on the input variable or the input array? The input list, actually. I'm pretty sure it does. So it modifies it in place. So when you use this variable later on, after calling sorted on it, it just remains sorted. No, it doesn't do that. So you actually have to assign it to a new variable. So applicant sorted, which is nlog n. If it's using a basic quick sort, I don't really know the memory usage of quick sort off the top of my head. Then there's also merge sort, heap sort, and all those other fun things. That I think heap sort. No, I named heap sort, it does use extra memory. Anyways, that's besides the point. Where like bubble sort doesn't use extra memory, but it takes n squared time. So now if I print apple sorted, apple, applicant sorted. I like saying apple though. Alright, so now we have down here N, Bo, J, Lee, everyone's sorted, everyone's good. People are happy. So let's have accepted students. We'll just make another list here because lists are fun. We'll go ahead and if A in test OK and a in int OK. Accepted students dot append a. And actually, these are uppercase, and the stuff in test OK is in lowercase, so we need to do a dot lower. I think you can just call that here. Maybe not. Maybe it doesn't realize what the entities and applicants are. So we'll just call this a low equals a dot lower. If a low in test OK and a low in interview OK. Then you can just do something like elif a low in legacy and then you can just do the same logic here, copy that and change this and to an or. But we only look for one of these conditions. So same thing, accepted student.append.a. But yeah, we want to append the uppercase version, since the accepted students is in uppercase. So let's actually just print this output. Alright, so now we have our accepted students, so we'll use an F string to format, and then since this is actually a list and the output is a string, we'll go ahead and I forget how to do this. And then we can't use the same things, the same quotes closures that we're using. Okay. Accepted students. I think this will work. So I'll go ahead and print this. Alright, sadly this isn't sorted anymore. But Anbo, me, my, and she. So Anbo, she, mo, my, me, my, mo, from C5. Yeah. I mean, I guess technically on this we are sorting a bigger list, whereas there's only 5 accepted students. So we can just go ahead and sort down there instead. We don't need to sort here technically. Oh, I am silly. So the reason, I'm just going ahead and use this because this is what our code originally had. You can get some speed increase if you sort the output list instead of the input list actually. But it's not very much. But if you had like 10,000 applicants and only 100 are accepted, sorting the output would definitely be milliseconds faster than sorting the input. But just to show you this works, go ahead, yeah, so accepted students, Anbo, Mo, my, she. And then to show you we don't necessarily need to do this, I'll just go ahead and then just show you we can do the different sort thing here. You can just do accepted students.sort. Can only join in iterable. So apparently this is not an iterable. Now it's sorted in iterable. I suspect it is. I could be wrong. We can always just try this. Yeah, so that works. So accept the students Anbo Mo my sheet. Still recording, right? Yeah, audio level's still good. Everything. Yep. We're using sets because these lookups are faster. But the problem with this is it's not an extensible system, which I want to get away from. But we'll go ahead and use some object-oriented coding to make this more extensible for inputting new students. So we can do something like class student. We actually don't need the constructors. Def init self name test okay, int okay, and is legacy. So we'll just go ahead and store these to local variables. Self.name equals name. Self.test okay equals test okay. Self.int okay equals int okay. Self.is legacy equals is legacy. So now we have a data structure to hold all the things we need for applying rules for students. I guess that's another thing you can do. You can make an interface for the rules. Maybe I'll try that in just a second, because we have two rules here. We have the legacy rule, and then we have the basic rule. So then, if we had a real system, we would have a application processor, or an application parser. Def init self. Actually, I don't think you need a self thing here. You can just do let me see here. I'm thinking. Get student details. We may or may not end up using this. Return high. And we need to def this, and we need to make this a static method. Now the other concern is, where do we want this application logic to parse? Do we want to parse it in the application parser, so like student is accepted? Or do we want to do it in, I guess we can just do it in the application parser itself. So this input to get student details would probably take like a application object, and maybe the application object is just like a collection of the strings inside of the application, and then you parse things out here, and then you return like a student object. I'm just trying to think of how we can translate our current input into something that looks like that, which I don't think we can. And I don't think we necessarily need to do that, but this is just a cool data structure that would probably apply in the real system. So let's get a student acceptor. Do we care about that? Maybe we just need a like a school data structure. Def init. So maybe the school, we have the school name. I think that's all we care about. So maybe this school name, def self.name equals school name, and then self.students. If we care about like sorting the students, how do we make a binary tree? I think we just use collections. Let me just look this up in my other thing real quick. If install binary tree, that's not what I want to do. I mean, I could just like write one from scratch, but that doesn't seem good. Yeah, I don't want to write one from scratch. Is there like a collection? There's gotta be collections, right? This thing is saying to use a sorted dictionary. Maybe that is what I end up using. Is it from collections, import sorted dictionary? Yeah, we'll go ahead and try that. From collections, import. Default dictionary, order dictionary. I don't think it's... Order dictionary is the same as the order dictionary, right? Sorted containers is an Apache license collection. Yeah, I think this is literally just the same thing. Alright, we'll play around with this data structure and make sure this is doing what I want it to do. Applied students, we don't care if applied students is ordered or not. Self-accepted students. This can be an order dictionary. Okay, so order dictionary is literally, no, order dictionary just remembers the order in which they get added. They don't actually sort them as you add them in. So that's definitely the wrong data structure. Jeez. How to store things. Just quickly look up the collections namespace. Collections Python. That's all in here. Maybe I can do that here. Is there a tree? Is there a binary tree? Counters, order dictionary, default dictionary, chain map, name level, DQ. All right, guys. We're just gonna use list. Sad to say, we're gonna use list. And then we'll use a get accepted students. This can just return sorted self.accepted students. Why not? def.add students. Add student will take a student object. We're gonna get rid of this application parser. I thought this was cool, but we don't actually need it. So first we will add them into the, kind of just want to use a set actually. I don't know if you can do sorted.set. I think set is still an iterable, so I think that still works. But we'll do self.applied students.add student. So just in case we need to keep a record keeping on all the applied students, you know, we can store them in an applied student dictionary or database table, and then maybe we have a flag like is accepted equals true or false, and then when we like dump the data when the application closes or when new students are added, you know, we can set the flag or not. So I guess like right here, you know, we could probably get these from database on load. So we can have like an internal memory object of them, and then, you know, a persisted data representation of them too. But for now, we're not going to worry about database complexity. We're just going to worry about a small little student scheduling system inside of you know, local memory application space. So for rule and rules, where would you do rules? Let's not worry too much about that. I think we still need all of these. Sadly. No, actually we don't. So for an applicant, what we're gonna do is parse each applicant into a student class based on our representation of what we care about for a student. Maybe in like a real thing, we care more about, you know, skills, history, GPA, all that other fun stuff, and then our rules could look at, you know, is their GPA, how many clubs did they participate in, what kind of extracurriculars did they do. You know, you can quickly see how these rules will get more and more complicated as the system evolves beyond beyond just test okay and these other guys. A dot lower, yeah, we don't care about any of these things. So actually, let's just quickly write the logic that converts it into a student. So student instance, student instance equals student, and then their name is just A. Name is just A. Test okay. A dot lower in. Let's move this down. We're going to convert our input data into actual classes, and then we can use the classes to abstract some of this thing, extend it, and use it as like an actual real system for each time we see new students. Obviously this is over engineering compared to what the problem is asking for, but we're just going to go through and look at this as like an object-oriented system. So I don't want to keep having to call a.lower, so I'm just going to do this here. ALO in test OK. Halo in int OK. Halo in legacy. So now we have a class, and now we will call our school. Our school equals, and what will the name of this be? We'll call this Python school. So why not? Just have a generic school name in case we need to add our schools to a central database of universities, or like you have one school and then you have like the engineering branch, you have the medical branch, the law branch, and then you can keep track of all of those students independently in the university. And then based on that, you know, you can look at acceptance rates and GPA average across specific universities and figure out things more data intensively there. So that's why it's good to abstract, break out responsibility of concerns, and separate those. So then we'll just do our school.add, and we'll apply in the student instance. So each time we go through an applicant, we're going to get a new student instance, and then we add them to our university. And hopefully this doesn't do something weird where it like copies data from thing to thing. These should return booleans, and then the booleans will actually get set for these objects. So this will be like true, false, true, false, true, false. And then back in our add student method here, we're going to actually put in rules. So get accepted students is actually returning the sorted version. So at the end of this, we should actually just be able to do our school. We don't need any of this. We don't need any of this stuff. Actually, yeah, we do. You can do a repr of the school. So the accepted students school string, you just do something like this. So we'll just store these in our local instance thing so that our string isn't too long. Keep hitting Mac commands when I'm on a Windows computer. I really want to just make a repr on these. You know what, just for the sake of showing you guys some of the magic methods, we'll just do this. We'll just make this a string. And again, we don't need all of this logic. We do need... I'll leave this all in line. Hopefully it's clear what's going on. If not, just leave a question in the comments. But yeah, this is making an f string, a formatted string, to insert the joined students using this internal character.join method. I guess it's not character, this is actually a string of a comma and a space. But now we should just be able to print the school. Well, actually the school instance, so our school. And this will use the built-in string method to convert this into a string. And our string is just the accepted students. Obviously, that wouldn't be what a string for a school would be, but I just wanted to use this because it seems fun. So, all right. Now we can just do something like this. If student dot and student dot interview, okay, self dot accepted students. And now we add, I guess we add the whole student, because it's slightly easier to, no, we'll just add names. You could add either or, but for the sake of making this logic a little easier, yeah, because this sorted is looking on classes instead of strings. So you would have to do something a little more complicated to get this. So I'm just going to add student.name here. But obviously, if you have two people that have the same name, you know, you have a Mark, and one Mark doesn't get accepted, but the other Mark does, you're not really going to be able to know which Mark to send to. So that's where this gets tricky. And you also need more info than just first names, which is why the system is not completely extensible, since you'd probably need last name and address, something uniquely identifiable. But even then, if you have like two Mark Smiths at the same address, they won't know who was the one that was accepted. In which case, maybe you have like social security number, or even email. Email is somewhat uniquely identifiable. But again, hold on real quick. Okay, we're back. Forgot where I was, but yeah, so these rules are a little easier to see what's going on here. Now, do you really need an elif here? Yeah, because someone might get added twice. Elif student dot is legacy, and then again we just copy this logic, replace it with an or. Hit the wrong button again. Alright, so now we have add students. We add all the students into the applied students, and we are adding this based on an object. And then here we are adding just the student name to the accepted students, which again, we'd want this to be a different kind of key, since names can be duplicated. But we're just going to choose to recognize that and not really deal with it right now, for the sake of brevity of this long video. Alright, so I think everything looks good. Created a school, created student instances. We're putting our school at the end. Let's not have too many things in. We're commenting to explain why we're doing stuff. We're using sets to make the lookups a little faster. And again, this would not be the input into like actual enterprise application code, but for our toy example, this will be fine, and we'll just parse the input as such here. Let's go ahead and run this. And look, you can see our accepted students and Bo, Mo, Mai, She are exactly the same. And then just to prove that we're actually using our thing, we'll go ahead and print, I don't need the spacing here, our school. And then this should just be a list or a set of the names in no particular order. And we'll use the F strings again just to reinforce how awesome F strings are. Accepted student set steed. And then we'll add our interpolation formatter here. Print this, and you can see accepted student set, and that's definitely a set because it's using a curly bracket, same names, and then our string representation of our school here. So that is, you know, taking this kind of relatively simple algorithm question, turning it into a system, calling out things that our system should be aware of. You know, maybe even an add students after someone is accepted. You know, this add method could be a congratulate student, and then congratulate student will add them into here and like send them an email and automatically like print out a letter and mail that out or something. I don't know. Like, congratulations, you are a legacy. Like, these could also have different emails. So this could send out a legacy email. This could send out a you did great email. So different ways to kind of think about the code as it evolves. But that's it, I guess. If you have any questions, let me know in the comments. And I hope this was useful for kind of like an OOP breakdown and thinking about things as an application. See ya.